Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss on a question related to equilibrium concentration. So let's get started. Chemical equilibrium plays a crucial role in predicting the final concentration of reactants and product in the reaction. When iodine gas and chlorine gas are introduced into a closed system, they shall react to form iodine monochloride. Given that the equilibrium constant for this reaction is 0.1, calculate the equilibrium concentration of iodine monochloride when 4 moles of iodine and chlorine gas are initially placed into an empty 1 liter reaction flask. Okay, in order for you to answer this question, the first thing that you need to do is you need to write the balance equation for the reaction. So the reaction consists of iodine and chlorine gas. So iodine gas plus chlorine gas will produce iodine chloride. This one will be in gaseous form as well. So next we are going to do is we are going to balance out this equation. So you have 2 iodine and 2 chlorine on the reactant side. So therefore you will have 2 around here. So this is your balance equation. So next up, what we are going to do is we are going to make the ice diagram. Question states here that 4 moles of iodine and 4 moles of chlorine gas is being used to produce the iodine monochloride, and the vessel is just 1 liter. So molarity is number of mole divided by the volume in liter. So basically the number of mole here is 4 moles, and because the vessel is 1 liter, so it's going to be the same as the concentration. So I'm going to write the concentration for iodine is 4, and then this one is going to be 4 as well. At first there's nothing produced yet, so the change will be negative x, positive 2x, and here it will be 4 minus x, and 2x. Alright, so given in the question, it states that the equilibrium constant is equivalent to 0.1. So we can say that Kc is equivalent to 0.1. Since all of this is already in molarity, therefore your Kc is whatever in the product divided by whatever in the reactant. So the concentration of ICl to the power of 2, because you have 2 here, so times the concentration of iodine gas and also chlorine gas. So we can also write 2x squared divided by 4 minus x squared, because it's the same thing. So yeah, and then you substitute the value of Kc is equivalent to 0.1 is equivalent to 2x squared divided by 4 minus x squared. Alright, so in this case, the easiest way is we need to do the square root of both sides. So I'm going to do square root of this and this. So leaving you with the square root of 0.1 should be equivalent to 3.1623. So you are left with just 2x divided by 4 minus x, right? So to make it easier, because we want to find what is the value of x, so this one you bring here, so you will get your 2x is equivalent to 4 minus x times 3.1623. So you just have to times 1 by 1. So you will get 2.3162x should be equivalent to 1.26649, because you just have to rearrange the x's on the on one side. Therefore you will get your x should be equivalent to 1.26649 divided by 2.3162, and your x should be equivalent to 5.4697 times 10 to the power of negative 1. So this is your value of X. Right, so looking back at the question again, they ask you to calculate the equilibrium concentration of iodine monochloride. So iodine monochloride at equilibrium is 2x. So 2x is equivalent to 2 times 5.4697 times 10 to the power of negative 1. So you will get 1.0936 molar. So this is the final answer for this question. Thank you very much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.